So the last things we're going to do for 8.6b is distance, rate, and time. So distance, rate, and time problems have a special formula. I don't know if you've ever seen this before, but let me show it to you. Distance, rate, and time uses the DIRT formula. Distance equals rate times time. So we are going to talk about a plane in this one. So a plane travels 100 miles against the wind in the same time it takes to travel 120 miles with the wind. Wind speed is 20 miles per hour. Find the rate of the plane. So to me, it sounds like our plane is going in two directions. It is going against the wind, and it is going with the wind. So those are the two directions it's going, against the wind and with the wind. So then we set up a little chart. So you put distance, rate, and time on your little chart and two rows, one being against whatever and one with whatever. So in this case, it's a plane, so we're going with and against the wind. You might have like a boat going with and against the current or something else. You might have like an escalator that you're going with or running, when you're a little kid and you run up the wrong side of the escalator or the stairs in the mall or something. That was always fun. So let's set this up. Sorry, Mrs. Black kind of got on a rant. Remember, you do not need to take notes over this as long as you're listening with the sound on. So first number I see says 100 miles against the wind. So is 100 miles going to be a distance, a rate, or a time? Well, distance is going to be a length. Mileage is something we measure length in. So 100 or miles. Rate is going to be a speed, and time is going to be hours, minutes, seconds, something. So since it says miles, it's definitely a distance. Okay, the next thing it says for a number is 120 miles with the wind. So another distance, but this one goes with the wind, 120. Notice with the wind, we went a little farther than against the wind. Let's talk about why that is. The next number it says is the wind. The wind speed is 20 miles an hour. So miles an hour, that's a rate, but don't put it in there just yet because the question says find the rate of the plane. So we actually have two rates. We have rate of the wind and rate of the plane. So x is going to equal what the question asks us. X is the rate of the plane, the airplane. So in my rate, I've got two things that are moving. The wind is moving and the plane is moving. When you are doing this, you always start with the object and then you do plus or minus the force acting on it. So in this case, the object is the plane, and the force acting on it is the wind. So the object could be a plane or a boat or a person, and the force acting on it could be like wind, or if you're in a boat, the current of the river, or if you're like a person and you're running up and down an escalator, the escalator would be here. So this is the object that's moving, and this is the force. So I know the plane goes first, then the force. So the plane is x, so my rate, x, is going to be there. Now, after that, I need a plus or a minus. Let's pause on that for a second. I know I also need the wind. So how fast was the wind going? The wind was going 20 miles an hour. So I need a 20. So I need either a plus or a minus. So let's talk about this. If I'm going against the wind, so think about one of those really windy days and you're walking straight into the wind. Are you able to go as fast as you normally would when you're walking into the wind? No, because it fights against you, right? So when you're going against the wind, you need to use a minus sign. When you are going with the wind, you use a plus sign. So because the wind, if it's at your back, it can kind of help push you along, or at least it did with this plane. So we also notice that traveled further when we were going with the wind, that can also be another clue that we need to use a plus here. And we didn't travel as far, so that can be another clue that we needed to use a minus here. Next and last, the last thing it says here is we have nothing in time. It says same time, the same time it takes. So what that tells me is that I need to set my times equal. But the problem is, it didn't tell me anything about time. So I have to figure out what I can use here. So luckily, I know that the formula is distance equals rate times time. So what if I wanted time by itself? Well, to get time by itself, I need the rate to go away, right? So I could just divide by it. So if I divide both sides by the rate, then that cancels, and my time, my distance divided by rate, would equal the time, right? So if I am looking for something to put into time, I can always put my distance divided by my rate. So my distance is 100, my rate is x minus 20. And down here, my distance is 120, and my rate is x plus 20. So we can now we have something in there for time, so I can set these two fractions equal to each other. So let's go down here and do that. So that's what it looks like when they're set equal to each other. So now yesterday I know we figured out the common denominator and we multiplied both sides by it. Well, today we don't want to do that because since there's only variables in the denominator, and since the denominators are different, it's actually going to take me longer to do it that way. So let me show you a cheat code. The cheat code is what you probably wanted to do yesterday, which was cross multiply. So we're going to actually cross multiply on this one. So let me set that up. So that's what it would look like cross multiplied. 100 times x plus 20 and 120 times x minus 20. Now remember, we're cross multiplying because there's only x's in the denominator, and in this application problem I'm going to let you. So hopefully you didn't do that on 8.6a. So now if you look at this, it looks like we need to distribute here, and we need to distribute here. So I have 100x plus 100 times 20 is 2,000. 120 times x minus 120 times 20 is 2,400. Okay, so now I need to get my x's all on one side. And since the 100x's is smaller, I'm going to move that to join its other x friend. So this side just has 2,000. 120x minus 100x is just 20x minus 2,400. Now we move this up and move the 2,400 to join its friend, who is a like term because they're both numbers. So this gives me 4,400 equals 20x. And the last thing I do is divide by my coefficient in front of my variable. So I find out that 220 equals x. We would have to use a calculator probably to do most of that if we can't do it in our head. So what does that mean? Well, x was the speed of the plane, so it means the speed of the plane is 220 miles per hour. I don't know if that's an actual speed of the plane, but I wanted to make the numbers nice. So when you're doing distance, rate, and time problems, make sure you set up this little chart. And remember, these notes are in my Google Drive. Or sorry, not my Google Drive, my website. Good luck, and please let me know if you have any questions.